Every year, we gather around a table built for comfort, tradition, and gratitude. But beneath the warmth of the holiday lies a colossal, unseen industrial machine that orchestrates the entire event. We consume sentiment, yes, but also millions of pounds of one specific dessert. This is the Built Bazaar story of how a single pie becomes a national obsession. We're tracing the journey of the Thanksgiving pumpkin pie, a marvel of engineering and logistics required to satisfy a population. This is the assembly line of American tradition, the historical foundation, from savory survival to sweet symbol. To understand the scale, we must first understand the origin. In 1621, the first recorded gathering between the Pilgrims and the Wampanoag was a pragmatic affair, a celebration of survival and a successful harvest. The pumpkin, a Native American staple, was present, but it was savory. It was roasted, stewed, or hollowed out and filled with meat, salt, and fat. It took 2 centuries for the pumpkin to fully embrace its sweet destiny. As colonial kitchens adopted refined sugar and access to spices from global trade, cinnamon, nutmeg, ginger, the pumpkin was transformed. It moved from the savory pot to the creamy, custard-filled crust. By the time Abraham Lincoln declared Thanksgiving a national holiday in 1863, the pumpkin pie was already an immutable cultural icon. Today, the production of this icon is a relentless cycle of precision, demanding specialized technology built just for one specific squash. Let's begin our journey to witness how your wonderful Thanksgiving pumpkin pie is made. Step 1. Sourcing and harvest. The true of the final pie hinges entirely on the raw ingredient. Forget the hollow, stringy gourds sold for carving. Commercial pie production relies exclusively on a variety of dense-fleshed squash, often a strain similar to the Dickinson pumpkin. Its low water content and high sugar density are non-negotiable for a thick, non-soupy filling. An estimated 85% of all canned pumpkin consumed in the United States originates from a single, concentrated region, primarily in Illinois, where the specific clay soil and climate provide the perfect environment. When harvest begins, the logistics are staggering. Custom-built harvesters, resembling colossal orange whales, move through the fields. These machines use heavy rotary blades and hydraulic lifts to gently scoop up the squash. Every year, millions of pumpkins, hundreds of thousands of tons, must be collected, sorted, and transported in a narrow, 6-week period. Step 2. The alchemist's lab. Transformation into puree. The processing plant is where the alchemy truly begins. The raw pumpkins enter a system of triple washing, tumbling through drums with high-pressure jets and rotating brushes to remove every speck of field debris. They are sliced by high-speed stainless steel cutters and immediately enter the steam chamber. This environment is tightly controlled, 240 degrees Fahrenheit for approximately 90 seconds. This thermal shock is critical. It simultaneously sterilizes the gourd and tenderizes the flesh while preserving the brilliant orange color and flavor compounds. Once steamed, powerful presses squeeze the life out of the pumpkin, separating the soft flesh from the rigid skins and seeds. The resulting pulp is forced through a series of fine mesh screens, a process called finishing that acts like a microscopic filtration system, eliminating all residual fiber and ensuring a perfectly smooth, velvety consistency. Finally, samples are pulled hourly for quality control. Technicians check the brick's level, sugar content, density, and color metrics against rigid seasonal standards. Only once the puree meets these specifications is it thermally treated, sterilized, and pumped into storage, ready to be deployed to the bakery. Step 3. The filling formula. Chemical precision. The pie filling itself is a feat of food engineering. This is a custard, not a simple batter, and its success relies on a non-negotiable chemical ratio. The starches and sugars, the white crystalline components, are first blended with the ground spices. The spice blend is the signature, often containing up to 5 distinct elements: Indonesian cinnamon, fiery ginger, piquant nutmeg, cloves, and allspice. These are measured down to the gram, ensuring flavor consistency across 2 million pies. Then, the bulk ingredients are introduced: the golden puree, evaporated milk for a dense mouthfeel, and the fresh, refrigerated eggs. The eggs serve as the emulsifier and the setting agent. In the colossal mixer, specialized paddles churn the ingredients for precisely 5 minutes, just enough time for the egg proteins to bind the fats and liquids into a stable, homogeneous emulsion. If the mixture is blended too long, it traps air; too short, and the custard separates. This precise timing ensures that the final product bakes into a smooth, non-cracked surface. Step 4. The engineered crust or the flaky foundation. A flaky crust is built on the restriction of gluten and the discipline of temperature. Industrial mixers are fed massive blocks of butter, kept precisely at 38 degrees Fahrenheit, combined with organic flour and ice-cold water. The machinery mimics the light touch of a pastry chef, cutting the butter into tiny, distinct platelets. These cold fat layers are what create the characteristic flakiness when the pie is baked. Too much kneading, and the gluten develops, resulting in a tough, rubbery dough. After mixing, the dough enters a chilling tunnel to rest, a crucial step allowing the limited gluten bonds to relax and the butter to re-solidify. This engineered resting ensures the crust won't shrink or tear when baked. Automated dividers then portion the dough with micro-precision. The portions are hydraulically pressed into the 12-inch pie tins. The speed of this process, a worker pressing and preparing a tin every few seconds, is staggering. Step 5: Assembly line and the furnace of feast. The final step is integration. The crusts move into the filling station, where specialized pumps dispense exactly 40 fluid ounces of the creamy custard into each shell. The margin of error is less than 1 ounce. They move, row after row, into the continuous oven, a furnace stretching over 100 feet. The temperature gradient inside is carefully mapped, a slightly higher heat at the beginning to set the crust, and a sustained, even heat through the center to coagulate the custard. The baker's true secret, however, is the exit temperature. The pies are pulled while the center is still visibly jiggly. This is the controlled underbake. This strategy accounts for the customer's home use. The residual heat finishes the custard on the cooling rack, and when the pie is later reheated in a home oven, it reaches perfect doneness without burning the delicate crust. After baking, the pies are subjected to a powerful flash cooling system, a blast of cold air that rapidly drops the temperature, setting the texture and preserving freshness. Within 4 hours of the dough being mixed, the finished, packaged pie is loaded onto refrigerated trucks. It is a logistical sprint, ensuring that millions of pounds of perishable holiday comfort are delivered in time for the single biggest meal of the year. The next time you sit down to a slice of pumpkin pie, remember the scale. Remember the thousands of acres of squash, the constant temperature monitoring, the precise ounces of spice, and the colossal, bizarre industrial machine that runs day and night so that you can simply enjoy a moment of shared gratitude. If you love peeling back the curtain on the hidden infrastructure and strange processes that build our everyday world, make sure you hit that subscribe button. Give this video a like, and tell us in the comments, what other colossal industrial process should we explore next on Built Bazaar? We'll see you in the next build.